Okay, so today we're going to take a look at what can we make when we take all the equations we have so far for velocity and acceleration, so we can make one big giant formula that will be an all-in-one formula and is really nice and time-saving. All right, so what do we know? Well, we have one formula for average velocity that says that is our displacement over time. And displacement is change in x. So I'm writing x minus x naught. So our final position minus initial position over time. All right, so there's one of our equations. And then we had an acceleration equation that said change in velocity over time. And so we can write that as v, so that's our v final, minus v naught, so our initial velocity over time. Now we have one more formula that we can work with, and that is there's another formula for average velocity. Just like you did in math class, whenever you want to find an average, you can do an average between two numbers by adding them up and dividing by the number of the sample, and so which would be 2. So if we have our initial velocity and final velocity, we just add those up, divide by 2, and we can have an average. All right, so we're going to rearrange these equations a little bit so that they are useful for us, and we're going to take this equation and solve it for x, because in the end we want a formula that actually is an x equal to formula. So I'm going to move this t over, and I'm going to move my initial over, and if I do that, I can say x equals x naught plus average velocity times time. Okay. Now I'm going to also do the same kind of thing over here with v. I would like this equation to be solved for v, and so that's my v final. So I'm going to say v equals our v naught, our initial velocity, plus our acceleration times time, because of course acceleration times time is going to be a velocity. All right, so these are our formulas that we're going to work with. And so the first thing we are going to do is we are going to take this formula over here and we are going to plug it in here. So I'm going to take this guy right there and I'm going to sneak through here and say, I'm going to place you right there. Okay, so let's rewrite this. So I'm going to write our x equals x naught plus, and I'm going to keep this all color-coded. I'm going to put v, whoops, I'm going to try. We have our v0 plus v over 2. All right. And then it's still going to be times by t. All right. So then what are we going to do? All right, I'm going to make this even more complicated. I'm now going to take, see this was a v equals formula? Well, I'm going to take this right here, and I'm going to plug that in right there. All right, and again, I'm going to try to keep this all color-coded. So let's see what this becomes. So I'm going to write x equals x naught plus, here's our big parenthesis, and I'm going to include that. So I'm going to write v0 plus, and I'm going to have that big 2, but now that v there is going to be replaced with our green formula for acceleration, our acceleration formula that we had solved for velocity. And I'm going to put v0 plus at, and then we have to finish the original equation we had with our little t on the outside. All right, so this is it, but we are going to just try to make it, clear it up a little bit with some math simplification here. So we're going to say x equals x naught, and what are we going to do first? I'm going to get rid of, let's see, I'm going to put these guys together. All right, so I'm going to have a v naught and another v naught. And because those are now together, I'm going to use a new color. So now we have 2 v naught. All right. and I've got to keep true to my equation, plus our AT, all right, all over the 2 from that one equation, and then our T on the outside. Okay, so what could we do now? Well, how about we get rid of, how about we cancel out those 2's? How about we distribute the 2? So I'm going to divide this by 2, and the 2 will go away. But then I need to divide my AT by 2, so I'm going to have to include that in there. So let me rewrite this again. X equals X naught plus, all right, so what are we going to have here? Just our V0, okay, plus, now we're going to get our 1/2 in there. Oh, I'm going to keep it the same, the correct color, since that was that. I'm going to put 1/2, and then I'm going to write AT, and then we're still going to have that T on the outside. Oopsie, I lost that parenthesis. Okay, now, so we're just taking the stepwise, and now I'm going to distribute the T. All right, so X equals X naught plus V0 T, so I distributed that T, plus, all right, what's it going to be? I need that yellow, because that originally came from that yellow formula. And then my A came from the green acceleration formula. Now I got 2 different T's here, so I'm going to have T times T, and because it is a combined thing, I'm going to make that back to a blue again. T squared. And there you have it. That is our new wonderful handy dandy formula. And we can see that different parts, right? It's all multicolored because these parts came from our 3 formulas, and then some are added together, and that's why in the blue. And so this is really going to be a great formula. So I'm going to rewrite this over here real big, and we're going to talk about what this now means. What does this formula really tell us? Because if you don't understand a formula, you start plugging away in it and not really paying attention, you can make a lot of mistakes. So let's talk about what each part means so that we can be true to this wonderful formula. Okay, so let's see here. First of all, what is this X? This X is your final position. This is, if you had a question like, where will you be if something happens, okay? This is our final position. This is our initial position. Normally, this initial position is going to be 0 because normally you're going to start from the start, and the start's going to be at, you're going to call that position 0. However, that doesn't always happen. Sometimes you could have something start in front of a starting line. This happens more if we do a vertical problem and you were to jump from a hill or something. So normally this is 0. Also, some people will take this, and if you bring this over this side, we would end up with X minus X naught, and then you could just have a delta X equals 2 formula. So many times, really, that's what we're looking for. Like how far, this would be how far. And many times the question will say, how far are you, or how far have you gone if, then we're really looking for delta X. So you can just scoot that over to this side, realize that delta X probably was 0 to start with, and so this is commonly what you're looking for. Okay, now what is this? What's V0 times T? This is like meters per second times seconds, which would be meters. So this is a distance, right? Velocity times time gives you a distance or a displacement. So this is going to tell you how far, but this is how far according to your initial velocity. So this would be how far if there was no acceleration. So if there was no acceleration, then this would be it. Okay, this would be how far you would end up going. However, we have this factor at the end here. And this part right here, this part tells you how much extra or less that you would travel, or how much extra or less your displacement, okay? So it's how much less distance or displacement due to the acceleration. Now, when is it going to be extra? When your A is positive. When the A is positive, it's going to be extra distance compared to how far with no acceleration. If A is negative and you're slowing down, then this last part of the equation is going to subtract from how far you would have gone. All right? And the 1/2 factor in here, this is our averaging. This is our averaging between your initial and your final velocities. Okay? The average of V0 and your V. All right? And we can see that came from this initial yellow formula over here. All right? So final position equals your initial position plus how far you would have gone if there was no acceleration plus how much extra you travel because of acceleration. Now, this formula can get really, many times this is 0. What if you started from rest? If you started from rest, then this part would also become 0, and we would definitely have a much shorter formula. All right? This is an excellent formula to use. If you didn't use this formula, there are cases, right, when you would have to use 3 separate formulas to solve your answer. But now we can do it in one big step, all right? But keep in mind what everything means so that you don't make any mathematical mistakes with this formula. Now, if there's another combined equation, if we would have plugged in things differently, we could have another formula that is another handy-dandy formula, and I'm going to give it to you here. So use this color. So if we plug things in differently, another formula you'd end up with is v squared equals v naught squared plus 2a x minus x naught. All right, this is another great formula to use. If you want to see the derivation, page 28 in your textbook goes through this on how you could do it. It's a very similar process at what we just saw here. Now, you go, why do I need a second formula if I got this great handy-dandy combined formula here? Well, take a look at this. What do you see here? There is something missing in this formula. What is missing? Out of all the factors here, what is missing in this formula? The deal is, what is missing there is there's no t in the formula. If there's no t in the formula, it means you don't have to have time. So this is a great formula to use if you have no time. Okay? Whoops. So keep this in mind, because sometimes you go, I can't seem to get where I want to get because I don't have enough information. So that's when this formula will come into play. Just remember, if you have no time, Ms. Jones says, go for this one. All right? So 2 new great formulas made out of the original formulas that you are aware of and have come to love. And now you have 2 more equations that will be your friends. All right, hope that helps.